Hi guys, it is Friday and that means it's time for Family Friday. Do you know what this is right here? This is so heavy, I can't even pick it up. And look, it's not just a rock, it's a very special rock. It's magnetic. Can you see how it didn't drop? It stuck to this really awesome thing that we have here. This is called a meteorite, and this meteorite is a very special rock, not your just common rock, but an even more special rock because it has some metal in it and it came from space. So not only is this rock 4.5 billion, that's more than million, billion. Okay, so this is 4.5 billion years old, and it weighs 400 pounds. Even if it was just sitting on here, you couldn't take this anywhere. So this stays here at the museum, and we got this beautiful space rock in 1939, and it came from the special space rock has to come from a special place, and it came from what is called Meteor Crater. And we're gonna go there today. So of course we have to do some vocabulary words. So when we are talking to special people at Meteor Crater today, you'll already kind of have a heads up of some of the vocabulary that we're going to be using, and you can keep your listening ears on for these words. Now, I have vocabulary cards here, okay? And they're different, but they come from this first thing, which is an asteroid. And an asteroid is way up in space, is a rock, a special space rock, and it has metal in it. And it's just orbiting, floating, going around up in space around the sun. Now, it's not a planet, because planets do that too, right? Earth does that. But this is a planet, it's smaller, okay? So, we start with the asteroid. Then, if a piece of that asteroid gets broken off from the asteroid, and then it's just kind of doing its own thing, then it starts coming towards our atmosphere. Then it is a meteor, when it actually comes pulling and sucked into our atmosphere, and it crashes, and some of it can even burn off. Then it becomes called a meteorite. If you noticed, I said kind of a big word. I said when the meteor comes to the earth and goes through our atmosphere, that's another important word today. And the atmosphere is the layer of gases that surrounds our earth, and it protects us from many things like asteroids and UV light, which those things could hurt us. So the atmosphere is all around our earth in space. We can't see it, but it protects us every day, okay? Then we're gonna do a fun experiment at the end of our program today, and it has to do with gravity, because when that meteorite is coming to Earth, it's being pulled, and that's gravity, okay? And gravity is the force of attraction that pulls together all matter. And matter is just anything that you can physically touch. And the more matter, or how bigger that something is, the greater force and the more of that pull it's going to hit the earth. Guys, we are in a different place other than the museum. Beautiful landscape here. And I have a friend here with me. Her name's Dorothy. Good morning, Dorothy.
Good morning.
So, can you tell us what this beautiful place is?
Well, this is Meteor Crater. Our crater itself was caused 50,000 years ago. due to a 150-foot meteorite that impacted this site. Fortunately, there was no people here at the time, but it created our 2.5 mile around crater in less than 10 seconds.
Wow. 10 seconds?
10 seconds.
I didn't know that.
Yeah, it's pretty amazing how something from outer space could do so much damage,
Impact,
yet
yeah.
beauty.
Yeah. Okay, so Dorothy, you said that a meteorite hit this land, but this is called Meteor Crater.
So it is. If you think about it, an asteroid, a meteor, a meteorite, and a meteoroid are all the same exact thing. An asteroid is what it is in space. A meteor is what it is when it comes through the atmosphere. A meteorite is what it is when it hits the ground. And when you find it on the ground afterwards, that's what a meteoroid is.
So, Dorothy, it's pretty round. So, does the shape have any good information? Why is it round?
So it does. So our meteorite actually hit at 80 degrees, so almost straight on, head-on collision. So it made a perfectly round crater, but if you look at it from above, it looks like there's a square drawn inside of it.
Wow.
That is due to 2 fault lines that we have here at our crater that actually make an X right in the center of the crater.
What is a fault line?
So a fault line is basically where 2 pieces of land come together, and when the ground shifts, those fault lines move.
It's kind of like, do you see where it's lighter colored there in the middle?
Mm-hmm.
Is that kind of where that X is at?
So
or
that's
the fault line?
basically where it crosses, yes. But that lighter colored circle is actually from a small lake that formed immediately following impact. Due to the amount of water that was in the ground before impact, it actually recondensed itself after impact and caused a small lake to form at the bottom of the crater.
Wow.
And that is 15 feet of lake silt that was actually left behind after the lake sank into the water table.
All right. So to look around, it's really flat,
Yes,
but this crater is pretty deep.
it is.
So why is that, Dorothy?
So when the meteor impacted before the meteor impacted, this whole area was flat. All of this lifted ground is actually due to the actual impact. The crater itself was about 1,200 feet deep on impact. It filled up almost immediately with 600 to 700 feet of loose debris that fell right back out of the sky. So today it sits at 550 feet deep, almost a mile front to back, and 2.5 miles all the way around.
Wow.
Yeah.
Okay, so would we have to kind of think that the meteor was probably about as big as this? I mean, how big was that? Do we know?
So it was 150 feet in diameter.
150 feet in diameter. So, Dorothy, where's the meteor? I mean, the meteorite. It's a meteor. It was a meteorite. So, where is it? Why don't we have a meteorite just sitting there?
So they say actually 20% of that meteorite, when the shock wave went into the earth, it also came out the back side of it. So it blasted 20% of it upwards and outwards into the surrounding desert. And then the rest of it, they say, melted or disintegrated on impact. It actually became very small sand-sized pieces of meteorite called spherules.
Experiment. Okay.
So these little pieces of sand that are on my magnets here, you can find for 7 miles all the way around our crater, right on top of the ground.
Wow.
This is all little pieces of meteorite.
Wow. So, what is making that sand stick to your magnet?
So the meteorite itself is made of 92% iron, 7% nickel, 0.5% cobalt, and then 80 other trace elements make up the last 0.5% of it. So metal is magnetic, so therefore a magnet sticks to our meteorite.
Wow. So Dorothy, I'm just trying to get my head, since we couldn't be there, I'm just trying to get my head around how this all happened. The best that we know of what happened. So first, you have to be in outer space. Okay, so we're an asteroid floating around in space. So how did it come from space to make an impact here?
So
What is the journey?
it actually started out in the asteroid belt between Jupiter and Mars as a large asteroid. It collided with a second asteroid, ended up actually breaking this piece off and throwing it out in space. Floated around for who knows how long out in space. And then there's two theories, I guess. Either Jupiter's gravitational pull grabbed it, brought it around the planet and threw it at us, or Earth's gravity caught it and pulled it towards us. So once the gravitational pull had it.
So this asteroid was even bigger up in space than before it got here.
Yep.
So it broke off and it hit here. How could something even so much smaller make such a big impact?
So the reason it made such an impact is because this meteorite that was only 150 feet actually weighed over 300,000 tons. And it was traveling at 26,000 miles an hour. So that's 7 to 10 miles per second. So if you could imagine something moving that fast hitting something that's standing still like Earth, this is what we end up with.
So how do we know? I mean, obviously it's not here anymore, but how do we know that a meteorite hit here and the tests that you've done?
Okay, so when Daniel Barringer arrived here in 1903 and discovered our crater, he actually did a lot of tests while he was here mining the area. He was trying to find where the meteorite went after it hit the ground. So one of the tests he actually did was shooting his gun into a pile of mud. So he could tell where the meteorite would have went if it came in at different angles. Every test he did, the crater came out perfectly round. So we know that no matter what angle it impacted our site at, we still would have ended up with the same crater, the same size crater, and the same shape crater.
Great. And we're going to do some more with that today. Not with a rifle, but we're going to have some other things to experiment with and find out just how interesting the studies that were done. So now we're inside of Meteor Crater. They have a wonderful visitor center museum part for everyone to come and visit. So Dorothy, what do we got here?
So this is the largest fragment of our meteorite that we have found so far. It weighs over 1,400 pounds. It's made of 92% iron, 7% nickel, 0.5% cobalt, and 80 other trace elements make up the last 0.5% of it. It's pretty amazing to be able to touch something that's older than Earth.
And how much do you think this weighs?
1,406 pounds.
Wow. So I can't just lift this thing and walk out of here, right?
Well, no, I don't think anybody could. There is nothing holding this down. It's actually just sitting on a metal stand with a box around the outside of it just to keep it stable. So we don't worry much about somebody picking this one up.
You said something very interesting, Dorothy. You were talking about touching something that's older than Earth. So there's a lot of history here. Can you tell us a little bit about that?
So it is a lot of history. So this piece here has been dated to be 4.56 billion years old. The Earth is 4.55 billion years old. So it kind of makes you think about how planets were made out in space, because everything that we have found in our meteorite has actually been found on Earth. So all those asteroids out in space are coming together to create a planet, which is how all planets were created, was just from different asteroids in space, stone and metal, coming together, combining to grow bigger and bigger and bigger.
Great, and we can study that here with the crater and with the meteorites that we have left over. And we're going to go to another part in a little bit of the center here, and we're going to talk some about the great history of the astronauts here, right?
Yes, ma'am.
Okay. Okay. So
So we're going to come over here to
Oh,
ground zero, which is going to show us exactly what happened when it came down, when it impacted the ground, and exactly how it created our crater.
Oh, wow, let's go.
All
Okay,
right.
we're gonna push the button. Wow, it's even vibrating in here. There it is.
Moving at 11 miles per second, a meteor raced through the solar system towards Earth. Immense shock waves were created as it approached from the east. Hurricane-force winds threw 175 million tons of material in all directions.
Got air.
The shock of
Got the air
impact
flowing.
melted most of the meteor and spread it with the large plume of debris. It took just 10 seconds and Meteor Crater was formed.
Wow. Now I understand why they call this ground zero. Perfect name.
Originally, in 1892, the USGS actually declared our site to be a volcanic steam vent. They didn't believe that a meteorite could come from the sky at that time, so they just thought every crater on Earth was caused by a volcano. It took us all the way up until 1960 before we actually convinced them all that we were actually a meteor impact site. So this right here is actually one of the characteristics that proved us to be a meteor impact site. Basically what it is, the layers of ground that were inside the crater actually flipped out and set themselves upside down on top of themselves. So creating a mirror image. That is called reverse stratigraphy. It's one of the characteristics that proved us to be a meteor impact site along with shocked quartz. But this is a very interesting way to look at the actual impact. And it shows how forceful it actually was because it actually was able to move the Earth.
Yes. So this here is the picture pre-impact. So before it got hit, the impact happened.
Yes.
And then look, this is a picture of that Earth actually being moved because of the force.
Yeah, it actually took these 3 layers and it just flipped them over, just like you would flip a pancake. And set them right back on top of the rim. So instead of 3 layers of rock, we now have 6 layers of rock in the rim of our crater.
Wow. So we were talking earlier about the amazing history that you all have here. And if you're talking about the history, you can't leave out the astronauts and the astronauts that came here. So tell us about that, Dorothy.
Okay, so one of the missions that the Apollo astronauts had before they actually went to the moon was to bring back a core sample of the moon. So in the 60s, to do a core sample, you had to have dynamite. I don't think they were going to take dynamite to the moon with them. They would not have made it very far. So we brought them here to Meteor Crater because it's the closest you can get to an actual moon crater to teach them about reverse stratigraphy, which we were just talking about.
Just talking about that.
So if they found a meteor impact site on the moon that had the same characteristic, then all they had to do to get their core sample was take a topsoil sample from the rim of the crater, because everything that belonged inside would be flipped upside down on the rim. So it made their jobs a lot easier when they went to the moon.
Yes.
They also tested their equipment while they were here. So they learned how to drive the lunar rover on the outskirts of the crater. They wore their spacesuits a lot of their training time because they had to learn how to do everything in these big giant gloves. So we actually had Neil Armstrong was walking up the trail one evening in his spacesuit and he tripped and fell.
Oh.
So when he did, he ripped a giant hole in the sleeve of his spacesuit. If that would have happened on the moon, we would have a completely different history than we have today.
Yeah.
But because of that, we actually redesigned the entire spacesuit to make it more durable and more rip resistant when he got to the moon. So if you look to the right,
Over to the ship.
we have the Apollo test capsule here. So this is an actual test capsule that they used to test how well it floated in the ocean, because that's where they were going to land. And then, of course, you know, Apollo were the first on the moon. We are actually in the process of training some geologists today to assist the astronauts when they go in 2024 to land on the southernmost lunar surface. So.
Oh, wow. So that's training that is coming up for astronauts.
Yes.
Wow. So unfortunately, it is time to say goodbye. But we have had so much fun here today, Dorothy. And it was so wonderful of you to take us around and tell us all this great information. Thank you so much.
You're very welcome. Just remember, there's a whole lot more to learn. We only covered a small portion of it.
Okay, so we're back at the Museum of Northern Arizona, and we have a fun experiment demonstration to do about gravity and to kind of help you to understand how that great big crater that we just saw. Wasn't that so much fun? And Dorothy was so fun to hang out with us and give us all that great information. It was such a fun day. So you can do this experiment at home, just like we do all of our other easy things. All of these things I have from home. So I got like a tray. Anything that you have at home that's like a tray, a cookie sheet, or even like a deep bowl would work too, okay? And what we're going to use as our soil, the ground, we just got flour. It's cheap, and you can probably have that at home in the pantry. Ask your parents. And we're gonna dump that flour right in our tray, and I'm going to smooth it out so it kind of looks, do you remember some of the views that were around the crater, how nice and flat it kind of was in that area? And that's what Dorothy said that it looked like way back when the meteorite hit it. Okay, so we have all different kinds. Some of the balls that we're going to be using today, like this one, is kind of hard. I like this one because it kind of looks like a planet. We have a bouncy ball. We have kind of like a hacky sack kind of beanbag. We have a cotton ball, because I think cotton balls are going to be a very good experiment with weight. Okay, so we have different weights. And we have this beautiful smooth stone. Okay, so do you want to start with the heavy one first, since our meteorites are heavy? So just imagine that this is our meteorite. And remember that gravity, once it hits that atmosphere, this ball now, or this meteorite, is being pulled to Earth. And it's going fast. Remember how fast Dorothy said the meteorite hit? And in like 10 seconds, it was crashing into the Earth. So you can come here and you can drop your ball. This is going to be messy. So make sure that you're doing it in clothes. That's okay to get messy. It will wash out. And be outside in a place that you could just sweep it, or the rain or snow will take care of it. But so we're going to drop it. And when I drop this, what is our meteorite, gravity is going to be pulling it down to our soil, our Earth. Okay? Whoa. Impact. That's like when we were at ground zero. Did you see how it really made that flower fly, or that earth fly? That's how you can kind of understand that image that we saw. It turned the ground all upside down like a pancake. Remember when Dorothy said that? And then you can also see that the crater it left is a little bit bigger than the actual meteor. So you could see how that impact, that gravity, really made a difference. Okay? Now we did something, that's my heaviest ball. So let's try something light as a cotton ball, okay? We're gonna do the same thing. It's coming from space and it's gonna hit, and I'll do it over here. It's gonna come, gravity is pulling it down. Wow, I didn't see any flower. That didn't make a really big impact. What did it? No. So remember in our vocab word, gravity, how much that matter, this is matter, anything you can touch, how heavy it is will make a difference, okay? So let's go. This is definitely heavier than our cotton ball, but it's not as big as our other one. So let's see what happens, okay? Again, it's coming from space. Gravity is pulling it down into our pan here, our soil. Woo! That made an impact. Did you see that? Now, I'll take our little, wow, it kind of made two impressions. It hit and then it kind of rolled, because you can see this one here has two impact spots where it hit and then it kind of rolled, okay? So I don't know, maybe some meteorites have done that, okay? Let's see, let's get this our neat bouncy ball, okay? Not as big as our last one, and this one is lighter. You can't tell that because you're not holding it, but believe me when I tell you this one's a little lighter, but it's made out of a rubber. So I wonder if it's gonna hit and stay, or is it gonna kind of bounce? It's gonna be interesting to see if it might bounce right out of here. Okay, so we're gonna see gravity working again. Oh, it stayed, okay? But it did kind of bounce out of the crater that it made. See how it made two little imprints there, two impact. Let's try our rock. Our rock is definitely heavier than our little rubber ball, okay? And let's see. Now it's not round. It's not perfect, it's smooth, but it's not round. So I wonder if shape makes a difference, okay? Remember they said at the crater, it looks round while we were standing there, but if you see it from space, it was square. It was kind of square with an X in the middle because of that fault line. So let's see what happens in our demonstration here with our rock. Wow. It did you see it? It did have impact. It did, ooh, I kind of made our crater. It definitely is kind of round. That was my fingers there. But this here, it's kind of oblong, you know, kind of like a circle and then you flatten it out. So it kind of did take a different shape since the rock was a different shape. The last one we have here, and I'll do it on our, we got some still flour over here, some soil over here that has not been disturbed. So we'll try our little hacky sack bean bag. It's pretty lightweight, but heavier than the cotton ball. So let's see. Whoa, that was a good impact. It flew some flour around, and look, it made a very good dent in our flour that, again, it's bigger. The impact here is bigger than the hacky sack. So this kind of gives you an idea, since we couldn't be at the site when the meteorite hit the crater that is now called Meteor Crater, we couldn't be there. But this is kind of a cool demonstration that you can do right at home to kind of be able to get an idea of what happened when that meteorite slammed into the earth so many years, millions of years ago. So guys, we had so much fun. At least I had fun. I hope that you guys did too, and that you learned a few things about a meteor, a meteorite, an asteroid. And if you've never been to Meteor Crater and you live around here, or you're making a trip out here, you got to put that on your list, as well as the Museum of Northern Arizona, because we'd love to have you. Bye.